Beautiful. Thank you, Ken, and thanks everybody for joining. Let me make sure that I'm all set up and you're able to see my screen. Great, thank you. So my name is Miriam Portes, and I've been in AWS for close to a decade. I am a partner sales manager, and what it means is that I've been helping aerospace and satellite customers to identify technology partners like Wherobots and system integrators like Spyrosoft in order to help them achieve their mission. And AWS have been, just for reference, quick reference, have been powering the geospatial industry for over a decade. We host flagship data sets like Landsat and Copernicus, Sentinel, all the Sentinel ones. But also we are hosting workloads for Airbus, Maxar, Planet, ISI. There's a slide with customer references, but we've been working for a while in geospatial. In the agenda that I have prepared for you, we'll talk about the market changes, the market trend that we're observing, as well as the AWS footprint in geospatial and the GenAI, the machine learning, artificial intelligence advancements. But before I get started, I want to give you some context on what the Aerospace and Satellite Business Unit is. We are a team in AWS, the cloud company, and we were created in 2021. The idea is to support the fast-growing space industry that is being fueled by the new space economy. And we work in the interaction of space and cloud. So we have people that come from, employees that come from like Satcom, satellite communications, building launches, working for NASA. And then we have people that come from cloud. They are technical people or sales that have been involved in the cloud. And in that intersection is where we operate, and we support not only geospatial, but also all the space value chain, propulsion and satellite communications and space exploration. And in here on the right, you can see our mission for geospatial. So it is basically bringing all the disparate geospatial data sets together, giving you the tools to create scalable architectures that you are able to drive innovation and impact in your business. So let's go into what we are observing, what changes, what trends we're seeing. And the first one that I believe that we all can relate somehow, it is the pressure that has the organization in order to deliver decision making fast and nearly real time. And an example would be like, for example, for disaster response or asset trackings. And this also brings us to the conclusion that latency it looks like it is the new competitive advantage for a geospatial company, or a company that works with geospatial data sets. We are also seeing an explosion of data. So not only volume from terabytes to exabytes, but we are also seeing diversity of data. So from satellite sensors, IoT, social media. And with all those changes, we're also seeing the proliferation of geospatial standards like can be, for example, GeoParquet, OGS API, COG, STAC. So with all of those three trends that I highlighted, I also want to give you like a more structured five things that we are seeing in the industry. So defense is still being the main buyer of Earth observation. And I have a slide prepared with that, but it's 45% from the 2024 Earth observation value. And then we have products. So customers are asking for resolution, for visit times, and real time. We are seeing like the system of systems growth. So platform of like orbit data, ground data, aerial data, all coming together with multi-sensor, multi-sources. Sustainability is also driving a lot of Earth observation activity with the new net zero strategies, like, for example, the carbon footprint, or, for example, also with the EUDR, so European Deforestation Regulation that came into place recently. It helps the Earth observation data. It helps in order to trace the evolution, trace the different objects that we are looking to obtain, as well as accountability for those players in the market. And last, but very, very important as well, is the AI that is driving so much innovation in the spatial intelligence, and especially also automating the processes and deliver and democratizing the access to spatial intelligence, like could be, for example, for chatbots, right? You don't need to be an expert in GIS. You can query in a natural language the system and get answers. This is a visual representation on what I just said. Data keeps growing and multimodal. So we are moving towards the payload diversification of multi-sensor ecosystems. And this slide is related to the defense being the main buyers. You see 45% of 2024 was defense the main buyer, and 3/4 are government, and then 1/4 is B2B. And in B2B is quite interesting because I was recently sat in a World Satellite Business Week session with investors, and they are looking at companies, startups especially, that they are not only like working with the government because, but also in commercial. Government sales cycles are a bit slower. Commercial goes faster despite of having more education to do. So that was a good insight that I took from that session. I also want to talk to you about the footprint of AWS in geospatial. So as you can see here, we have a full geospatial data cycle from acquisition to analyzing. So you take it like we even have antennas that talk directly to the satellites, or you can use IoT or use open data, and then put it in the S3 bucket, which is our main storage, and then process it with TC2, EMR, then deposit those outcomes into the different types of databases that we have, relational, not relational, and data warehouse. And as well to that, you can add layers of artificial intelligence as well as the visualization. However, assembling all those building blocks, it has, despite of having been the way we worked with geospatial companies, and Spyrosoft has been a key player helping those customers putting the building blocks together. We need to acknowledge that it takes time and engineering time, so that is cost and that is time. But also you need to integrate like Spark, Sedona, Iceberg, the indexes, the spatial indexing, and then tuning for vector and raster and the metadata governance. So it's a lot of work that has to go into place in order to to create a platform that is able to provide that spatial intelligence. That's why we're about that opportunity in the market to offer a scalable and optimized data platform for that spatial intelligence. And it is we are seeing our customers to fast adapting Wherobots, and that's why also Spyrosoft has been specializing more and more on how to help customers companies to build on top of Wherobots and to add extra layers of GenAI, which is really important, and we'll talk to the third part of this presentation. So Wherobots is powering a production-ready data lake created by the founders of Apache Sedona, and it helps processing large-scale distributed spatial data and AI inferencing. But I'd like to pause a little bit and understand what's behind all of this definition, because what it means production ready is that it's available for you on day one. You don't need to assemble. You don't need to. It's just there for you to use to inject data and process it. It's managed, so it means that you reduce the overhead maintenance cost from your engineers, because Wherobots it's managing it for you. It's aligned with Opera standards, so formats like Iceberg and GeoParquet is tuned for vector and raster, and it's to help processing in scale. Also really important, you don't need to copy data. It brings the compute where your data is, wherever it is in different clouds. And also uses pay-as-you-go, which is important. It's built on AWS, so by working with Wherobots, you're inheriting all that scalability, all that security, all that reliance that the AWS clouds bring to you. So it is an absolutely great solution for your engineers to focus on the mission. And Spyrosoft is also here to help you with that Wherobots, what you're building also on top. Whereabouts is a marketplace from AWS Marketplace, which is a digital catalog. We have 20,000 product listings, many security data. SAP, for example, is in there. Many software companies. And the good thing about the marketplace is that you get a consolidation of billing. You can use Sedona, you can use Whereabouts, you can use other software, you can use AWS for other work streams, and you only get one bill. And this actually brings a lot of streamline and agility to your business, and your procurement will love it. Also, really quickly mentioning that AWS has more than 250 terabytes of open data, like Landsat, and all Copernicus missions. So satellite 1, 2, 3, 5P. So a lot of data for you to leverage in the AWS cloud, and Spyrosoft and Whereabout is also planning to integrate it in the platform just to make things even easier for you. Here in this slide, you can see some geospatial and Satcom companies that are delivering intelligence on AWS at scale. And one of the questions that I get quite often is why AWS for AI, right? Why is the hype? And if you think about it, we've been in Amazon.com, we've been using machine learning for recommendation, like engine recommendations and supply chain optimization. I recently was in a fulfillment center of AWS, and that was mind-blowing how robots move, how they use different selection as they move, how they point with light to people, how to what items to take to be fast, and how all that infrastructure communicates in one point for all the items for the buyer. It is mind-blowing. So what I want to say with this is AWS have been using machine learning, and they are battle tested approaches that we build in products in services to give it to you, because what we want to do as a company is democratize the use of technology regardless of the size of the customer. So it's available for you. And another important point is what's behind of chatbots, of LLM that nowadays are very it's very extensive in our day-to-day. Think about it. There is a massive compute power, a specialized hardware, scalable infrastructure, and AWS is helping revolutionize the AI, because we're also building our own chips. That one is called Trinium, and the other one is Inference. They come with 40% better price performance. So this is very important, because that 40% price performance can make the difference of a project of yours being viable or not. Let's dive a little bit on AI. I put this slide in here because AI, machine learning, we all use it interchangeably. But the point here that I want to make is traditional machine learning and spatial intelligence have been used mainly to identify for computer vision, identify patterns, and as well as future prediction based on this historical data. What do we think is going to happen in the future? But what is changing is the GenAI. GenAI is a branch of deep learning that brings new content and creates new content. And those are powered by large pre-trained foundation models. And this didn't happen overnight, like people might think. This is a combination of proliferation of data, scalable compute capacity like AWS Cloud, and innovation in machine learning, especially in deep learning and neural network technology. I wanted to give you some use cases. This is not limited to those use cases. There are many more, but we're seeing some of our customers using GenAI in order to create synthetic data, generate enhanced predictive scenarios, determine what images have been edited, and using natural language like the chatbots that we see everywhere. And the big difference about the generative AI is that you don't need to label data. The foundation models, they are pre-trained vast amount of unstructured data. They are trained on billions of parameters, so they make them really intelligent and learning to understand complex context. What makes the big difference is that with traditional machine learning models, it was one model for a use case. Now you have a foundational model for many, many use cases. And you can tune them. You can customize the foundation model via the retrieval augmented generation, so giving more context to that foundational model, or via fine tuning as well. Here, there is an example of how ISI have been utilizing GenAI. So for the response, disaster response in building that situational analysis, they've been using social media photos, which are georeferences, to understand, for example, in that photo, this photo of Spain, to understand how much is the depth, how much was the depth of the water in those photos. So that's how they were able to reconstruct the awareness of the ground in 24 hours for 80%, while it would have taken a year to do that before. And another one, chatbots, is how the gas have been building chatbots, combining the satellite weather data, proprietary ground data, and the best practices of agriculture. So all of that in a chatbot. So it has impact the life of 46,000 farmers in Ghana. And 95% said that they had an increase in income. So that's how technology is being used for an impact. In terms of the different layers that we have in AWS, I talk about Trainium and Inferentia as infrastructure. We also have the SageMaker. You might hear about that. It's just to build, train, and deploy the models. But we also have ready-to-use services like a Code Assistant, Amazon Q Developer, and Amazon Q Business. And in the middle of that, we have Bedrock that is really well adopted with our customers. And the main reason why is because the feedback that we get from our customers when they look at AI is, I want to have like enterprise grade security. I want to have the best model. I don't want you to tell me what foundation model I need to use because I still don't know. I need to test with my use case. And the third one is I don't want vendor locking. So Bedrock, it's a platform fully managed that that allows you to create GenAI applications and give you access to third-party foundation models via API. So with the same API, you can test different foundation models. So it's very well adopted in our team, in our customers that we work with. And with this last example, I want to show you agentic AI. So basically, you can query this chatbot about where should I build a house with these characteristics? Where would that be allowed legally? And can you also draw it in the map? So before you would have to get like legal team working on this and the GIS engineer working on this. And now what it does, this LLM is in the backend has agentic AI, this agentic. So they have agents that they are autonomous software that is able to understand the question and reason and take action. So what it does in the backend is checking with the legal repository about the zone regulations, as well as talking to the map in order to draw the relevant areas where you can build that type of the house. And to conclude, I want to make you aware that AWS has a GenAI Geo Challenge that we are doing with Thrive Geo and Women in Geospatial, but also to invite you to submit your Think Big ideas. The deadline is December 7th, and you have access to one of the prizes, like up to 650K of cloud credits, technical support, and all of that. So we would love to see your submission. But for now, I just want to thank you for your time and just remind you that you have Geospatial special domain expertise with Wherobots and Spyrosoft, and we want to be your cloud of choice. So happy to help. Thank you. Over to you, Ken.
Hey, thanks, Miriam. Appreciate that background. I'm going to launch a quick poll here. This is to keep the participation going between us all here. So let me just get that launched real quick, which I just blew there. And then, yeah, Kyle and I are going to show a quick overview demo of some of the Wherobots platform. And then we're going to hand it over to Michael at Spyrosoft to kind of bring it all together and show us, how they can bring the entire solution together here. So let me share my screen. And Kyle, just confirm you're seeing the right screen there.
That's correct. Yeah.
Okay, thanks. All right, and this is just following on. This is some just market intelligence, kind of the same thing that Miriam had said in her presentation. What we're seeing is that there's a lot of data being generated. There are so many satellite providers now, and literally at every show I go to more and more, there are thousands of satellites, up from the 50 back in the day that are now observing the Earth and sending back analytics and data and images, which is great. It gives us great opportunity to pull more insights out of that for all kinds of different industries. And there are all kinds of industries that are extracting value from this, from agriculture, finance, real estate, energy markets, and so many more, transportation, logistics organizations that are getting that value. But what's been identified in the market is kind of this gap in the middle here of getting those raw images and being able to process them to extract the value. And as Miriam was showing, AWS gives you lots of tools and things to build that out and do that. And there are people doing that today, but it is a difficult process that has to be pulled together. So this gap here is exactly where Wherobots fits in and what we've built our platform for, to enable you to extract the value out of those types of data sets in a very simplified, easy platform. We are the spatial analytics platform. So whether you're bringing satellite imagery, drone imagery, or other mobility, GPS, vector data, ground truth, and even other data sets, you can bring all of that together and combine it at what we call planetary scale. Because this platform is built on a serverless architecture up at AWS, and it is a distributed architecture based on Spark, we can run very, very large workloads where traditional GIS solutions typically can't scale to that type of load. We can do that on a nationwide run and even global runs. Just for example, we do a United States, a full USA nationwide run on all the road networks. And we do that in about an hour or two, and it costs about $100. So that's the type of scale that you can run and gain more insights out of, as opposed to having to limit it down and cut down on the areas that you might be interested in. You can do full analysis across all the data sets as frequently as you need to, and do that quickly so you can iterate on the data and get that spatial intelligence insights out of this data. Now, as mentioned too, Wherobots is based on Apache Sedona. Apache Sedona was built by our founders, Mo and Gia, from the ground up to be a geospatial database and analytics platform. So it is a spatial first platform. There's lots of great analytical platforms out there, but none of them were built with spatial in mind as a first class citizen. So that's really kind of the core fundamental difference. And when they launched this as open source back when they were still in college, it was picked up by a lot of large companies that you see here very quickly that process a lot of spatial data because of the efficiencies that are gained by doing the analytics on this type of platform. You can see anywhere from a 5 to 20x performance gain because on spatial analytics, because of the architecture, because of the indexing, the spatial index, and the way that platform is built. And you can see there's over 50 million downloads. These organizations are folks that we work with to either support their open source deployments or discuss with them the benefits of moving over to Wherobots as the hosted technology. So Wherobots itself is built on top of Sedona, and they're fully compatible. The difference being that the Wherobots platform is hosted, fully managed, scalable. So all the operational things you might have to do if you're downloading and running your own open source, a lot of that would go away, and you just have to type in an email to get going and start getting value from the platform. The platform is hosted in AWS for all that compute. It is a data lakehouse architecture, which means that you do not need to move all your data to our platform for us to do analytics on it. Of course, if it's stored on S3 and more local, you'll probably have some performance benefits, but GIS data can be everywhere. Public sources, local sources, private sources that you may not be sharing with others. So our compute can attach to those different data sources as long as you just give us the credentials. And then we're able to bring the compute to the data. So you're able to do analytics across all those data sets, join them together, and then get those results that we can put back into your database or your workflow there. So the key to a data lakehouse architecture is there doesn't need to be massive data movement. We'll bring the compute to that, and these data sets can get very large. So we can attach to that, bring it all together. And the other thing that we provide is the ability to normalize and bring those data sets together so that they're usable on a single platform. So for instance, normalizing and joining raster imagery can be challenging. Preparing images to do vision models and analytics on is a big part of the process. And there's lots of different satellite imagery providers, format, file types, zoom levels, etc. So one of the things we do is normalize that, bringing into the platform, and also bring it to a modernized format using Iceberg and Parquet so that it can be shared with other platforms. So we can bring in and what we call mosaic those images, bring them together, align them, clear cloud cover, and prepare good imagery that can be used for analytics, right? And on the AI and kind of the machine learning discussions, you only get results as good as the data that you are working with. So what we do is we prepare and clean up that data so that it can be used for those types of analytics. And we simplify that part of the process. The platform also lets you run vision models at scale. So once you have the prepared images to use, you can then bring in any model you want to run on the platform. So Wherobots itself is not a model builder or maker, but what we do is provide a platform that Kyle will show you very simply is able to run a variety of different vision models on with just a few lines of code. And then we scale out the process, we spin up the GPUs, we get all, do all the detections, get the analytics, return the results, and then we shut the entire environment down. So you only pay for the seconds of compute that you are using to run those jobs. And if there's no job running, there's no payment. So because we can run jobs at such high speed and in a serverless fashion, it's typically extremely cost effective versus other methods or trying to do it in-house. And then on the final part of that too, that Miriam brought up too, is we have an MCP server attached to our platform. So once you have those analytics done and you want to interact with it in a agentic way or in a more natural language type way, you can just access that from an MCP server that we have attached to the platform. That server is trained in our coding, SQL, spatial SQL, so it'll enhance any requests going in to make sure that you are getting good information and data back and not any kind of hallucinogenic things. So we can really be that ground platform of truth to ensure you're getting good spatial results so that you're feeding good data into your workflows so that anybody interacting from an AI perspective gets good results. So that's just a quick overview of the platform and where we fit in. Kyle's going to show you really a quick walkthrough on how easy it is to do all that. And then Michael from Spyrosoft is kind of going to bring this all together in a big project that they've been running as well. So with that, I will hand it over to Kyle.
Great, thanks, Ken. You able to see my screen?
Yes.
Okay. So as Ken mentioned, we're going to walk through just how easy it is to get up and running with computer vision in Wherobots. And what we're going to go through today is the application of two different models that we support out of the box. Meta's Segment Anything Model 2, SAM2, and Google DeepMind's Open Vocabulary Object Detection, OWL v2. And so like any Spark workflow, we're going to start by initializing our context. And once we have that instantiated, we're going to go ahead and load our imagery. And so in this case, we have a number of we have a GeoTIFF and an S3 bucket, and we're going to read that using our Wherobots DV raster reader, and we're going to apply just some quick options to tile that imagery. And so what we get back from that is what we call an outDB raster. It's essentially like a lazy loaded raster, so we're not actually loading it into memory. We're just storing a representation of where that raster lives in storage and preparing that for running inference. And so here we'll just visualize what that looks like. So again, with one quick function here, we're able to read that in. We were able to tile it across the entire scene. And here we have the vector representation of those footprints. And just to show what those constituent image chips look like, here's a subsample of those. So you can see we've got some aircraft and such at the airport there. And let's get into running inference. And so to run inference on Wherobots, all you need to do is pass in the raster data and call the function to segment. So we have RS segment, text to segmentation. There's a couple different functions, but in this case, since we're pulling in the SAM2 model, we specify that model ID. We give it a text prompt for what it is that we're looking to segment from the image. In this case, airplanes, and we apply a threshold for the confidence value in our predictions. And so with a single line of SQL here, we call that function text to segments, takes the model, raster, the prompt, and threshold, and that will create a prediction data frame. When we get the result of that back, we're able to filter on that confidence label and get back a well-known text representation of each of the detections. We can also get a bounding box, which we'll go into a little bit later. And here just showing that prediction. So these are the polygon that represent the different detections. And we can explode that out here, and you see the confidence score. We only have one class, so our labels are 1, and then the well-known text for the segment. Visualizing that on a map, you can see here our airplane detections. So we've got an outline of the shape or of the aircraft itself, and you can see throughout the scene those are captured. Additionally, as I mentioned, we can do bounding box detections, and so we'll switch over to using OWL v2. Same setup here, except just a different model. So airplanes is the prompt threshold over 0.5, and this time we're calling our text to bounding box function. And so what that will do is just return a minimum bounding rectangle that encapsulates each of the detections. And similarly here, we're going to filter our results, and we'll explode those out, similar to the result we just looked at above. And here we can display those bounding boxes on the map. And so you can see the detections scattered around the airfield, encapsulated with the minimum bounding rectangle that best fits them. And here we just show some examples of what those detections look like on the image chips themselves. And so that's really just how easy it is to get up and running with AI in Wherobots. We aim to make it very easy to get at insights and allow you to quickly enrich data and arrive at valuable determinations that you can share to enhance your business practices. So with that, we'll hand it over to Michael for the more formal demo. Thank you.
Cool. Just launching another quick poll while we're switching over to Michael and his overview and demo. So if you don't mind jumping into that one, that would be appreciated. And again, if there are any questions, there's a QA bar. Just feel free to type them in there. We'll answer them live as we go, and we should have some time at the end to do live Q&A if anybody wants to come off mute and talk about that. So yeah, so give a quick click there on the poll, and we'll hand it off to Michael to get going.
Right. Thank you, Ken. Thank you, Kyle. So, right. Hope I'm sharing my screen right now. I should be able to see my presentation.
Yep, all good.
Perfect. Right. Hopefully Zoom cooperates today. Last time I shared my screen a couple of days ago, it just crashed my browser. So we'll see how it goes. Previous presentation went well, so we'll see. Hello, everyone. I'm Michał Wierzbiński, and today I'd like to show you how you can run large-scale deep learning inference and analytics jobs using Wherobots platform. Quickly about me, who am I? I'm a principal AI data scientist at Spyrosoft. I have over 7 years of industry experience in AI and data processing. I started out as a cloud engineer with Azure, but spent the last 5 years building AI and ML services for various clients in various industries. I specialize in building cloud-native geoanalytics platforms, specifically targeting large-scale vector and raster data processing. About Spyrosoft, our company, Spyrosoft Group is a leading software development and consulting agency with over 2,000 engineers worldwide. We currently are working with over 300 clients across not only geospatial, but also in IT, finance, cybersecurity, e-commerce, automotive, healthcare, and multiple other industries. Focusing solely on geospatial, our main partners and clients here are UCRI, UK Research for and Innovation Center, Ordnance Survey, one of the biggest mapping organizations in the world, LandUp, you might know them from TV series Clarkson's Farm. They are managing all of his land assets there. NCTech, they are delivering Street View imagery for Google Maps. We also are official partners for Esri UK. We also work with multiple other organizations and clients. Unfortunately, I don't have the time to present them all to you today. As for our geospatial expertise, we cover the full spectrum from acquiring and processing spatial data to building intelligent, scalable geospatial solutions. Our core areas of expertise are in-Earth observation, geodata engineering, location intelligence, and GIS solutions. We're experts in multiple areas, for example, automated picture extraction and attribution, which you'll see an example of soon. Raster vector map tiling and processing, spatial temporal imagery processing, and multiple others. Altogether, our expertise enables us to build robust geospatial solutions from data acquisition and processing to cloud deployment and intelligent analytics. We're supporting clients across many domains here. And after the demo, so what we'll do today is we'll use a deep learning model trained on FLAIR dataset. It takes as an input high-resolution satellite and aerial imagery and generates segmentation masks for 19 distinct classes. So the goal here is to assign one of those 19 classes to each pixel of the input image. Just for the brevity, we're going to focus only on building class. As for a source of our data for analysis, we'll use around 10,000 square kilometers of GeoTIFF images downloaded from our local Polish geoportal. Specifically, we'll cover full area of Opolskie voivodeship. And off to the demo. All right, I can't escape the presentation mode, which is interesting. Give me a second.
Yeah, we're seeing your slides still.
Yeah, I'm holding escape key, but it won't let me.
Maybe just stop sharing and reshare then, yeah.
Yeah, probably. Let me quickly stop sharing. All right, now share screen, screen one. I knew going full screen was a bad idea.
Yeah.
Linux. Right, going back to the presentation, to the demo. So the first step actually is about data. So before we go to the model itself, we're going to look at the Wherobots platform. So if you go to the storage tab in your organization, you'll get access to this shared space as well, as I do here. So we've uploaded all of our GeoTIFF images in here. You can see that there are over 200 pages of smaller GeoTIFF files, around 40 megs each. If we try to visualize this data, this is how it looks like. So it's just a small GeoTIFF file, like 2.5 kilometers by 2.5 kilometers. And as you can see, it's of very high resolution, 25 centimeters per pixel. So we've uploaded this data to the Wherobots platform. And with that, we're ready to begin our analysis. So as Kyle previously shown, Wherobots uses Stack MLM extension model, which you need to register before you can run any of your analytics. Wherobots has a great documentation about how to do that. So I'm going to just skip that part altogether. You can go ahead and go to the documentation page, read about how to create those metadata files and how to compile your model into this compatible format. As well as they also have a bring your own model tutorial to do exactly that as Kyle also demonstrated in his presentation. One thing from my side maybe to keep in mind, currently Wherobots only supports inference using CUDA devices, so NVIDIA GPUs. So whenever you're trying to compile your model using Torch AOTI package, make sure that you're also using CUDA format, otherwise your inference will fail. And double check your model inference after you've compiled it to see whether the predictions still make sense. So in here, I'm double checking the model predictions, and the inference still looks like it's correct. So we're all set and good to go. Right, and for the inference part, we're going to set up our Sedona context. We're going to load all the GeoTIFF files that you've seen from our S3 storage. We're going to use the same mechanism, the raster reader, as Kyle did. The only difference here is that our chips our GeoTIFF tiles are already pre-tiled, so we're not going to enable retiling option. We're going to tile them manually to model expected format of 512 by 512 pixels. First, we're going to create a raster table, iceberg table in our organization, to which we're going to upload all the tiles so that other users in our organization don't have to do this twice. And using rs tile explode function, we're gonna tile all those individual raster tiles into smaller 512 by 512 rasters. And finally, we're going to save them to tiles table. And this is how the data looks like. Again, we have out dbgrid abstraction over them, which will lazy load all of the necessary tiles when we run the inference. Loading our model from storage, you can see this is the metadata format, stack MLM that we're going to use. Just double checking that everything here is as expected. We're going to load all of that tiles from iceberg table and create a temporary review with them. And then, just like Kyle demonstrated, we're going to use rs segment function to segment all of the individual tiles into confidence arrays. So the result from this function is this confidence array, which will give you confidence score per pixel, and also the corresponding class map explaining which pixel belongs to which class. Since we only have per pixel classification scores, we need to generate geometries from those confidence matrices. To do that, we're going to use rs segment to geoms function, which will take as an input both the raster and confidence array, as well as a class map with minimum confidence score we want to generate our geometries from. As you can see, as a result, we're going to get a list of polygons together with corresponding labels within those individual raster files. So for example, this particular tile has as a result a multiple polygons together with multiple detections, multiple segmentation classes that are found within that individual tile. Since we're only interested in building classes, we're going to filter out those predictions using our metadata from the model itself. We're going to focus on the building class. We're going to run a quick lookup. We're going to filter out every single empty prediction, and we're going to focus only on predictions containing building classes. And as a final result, this is the table that we're going to get. And again, we're going to save all the predictions into our organization's iceberg table catalog, just so that we don't have to run the whole inference twice whenever we want to work with building predictions again, because this whole job takes a couple of hours to go through all of that 10,000 square kilometers. So let's not do that twice to incur even a bigger bill. And we're going to have run through analysis notebook here. So again, we're going to set up a context for Sedona. We're going to install some packages, additional dependencies for visualization using GeoPandas. And then we're going to load the same predictions that we just saved from Iceberg table. You can see that we have over almost 370,000 individual geometries. And we're just going to load the geometries we're going to teach us in confidence scores for that for those predictions. You can see those predictions on the map in here. As you can see, they are covering a big chunk of Poland here. If we zoom in a bit, you can see the predictions in details. Zooming on Opole city, you can see the predictions are still making sense when we're zoomed in. So it looks like the model performed its job rather well. And once we confirm that everything seems fine, we can run some analytics. Before we do some statistical analysis, we're going to calculate extra features like area parameter, centroid, and bounding boxes. We're also going to transform the data, reproject it from EPSG 4326 to our local Polish 2180 EPSG code, just so that we are working with meters and not degrees anymore. We're going to compute total build-up area for Opolskie Voivodeship. So in that case, it's slightly over 46 kilometers squared. And the total percentage of the whole Voivodeship area is around 0.5%. So it's not much build-up area for the whole Voivodeship. Which also makes sense because Opolskie is mainly agricultural land, forests, and open areas, not much build-up and city centers there. If we want to run a statistical analysis determining whether there are any outliers in the data, we can use percentiles. So in this case, we're calculating percentiles ranging from 1st to 99th percentile. And as you can see, over 75% of buildings for this particular voivodeship has area smaller than 134 meters. Same with perimeter, only 50 meters. Like 75% of all buildings have area smaller than 52 meters. So mostly we're dealing here with individual family housing. There are not many industrial areas or large-scale housing buildings, which also makes sense. And if we want to see if there are any outliers in the data, we can use either quartile rule to determine those. So basically for area, we do have in the upper end over 30,000 outliers. So there are some large-scale buildings in predictions. We don't have many, or we don't have any at all, like tiny buildings that are outliers in here. And if you take a look at the parameters, the results are similar, 25,000 geometries that are outliers on the higher end. If we visualize this data, you can see that the histogram for the area, the distribution is heavily tailed. It has a skewed distribution. There are some geometries that exceed 5,000 square meters in area. So those are probably industrial areas that were being segmented out. We can also run spatial analysis using gridded statistics. Like for this particular analysis, we're going to use H3 cells. So H3 is an algorithm and that was developed by Uber. For their purposes, we're going to use the resolution of 8, which gives a good balance between like coarseness and it's no longer too fine detailed, but also not too coarse for our purposes. Wherobots comes with built-in special functions for handling S3 geometries, so we can aggregate all of the building centroids and calculate how many buildings there are per H3 geometry. And this way we're getting building count per H3 cell, and we can visualize building density on the map using GeoPandas this time. And as you can see, for main city centers like Opole and up in the north for Prashka town, we have the biggest concentration of buildings, almost 900 buildings per H3 cell. The rest of the cells is quite empty, to be honest. Not many buildings in those areas, since Opole, like I mentioned before, it's mainly rural areas and and forests, basically. We can also calculate build-up ratio, which is the sum of building area that's divided by total area of the H3 cell. Again, we're going to use some SQL magic to calculate all of that, and again visualize all the results on the map as well. The results are following more or less are in line with what we had with the building density. So again, main city centers have biggest contribution of build-up area per H3 cell. And with that, I believe we've concluded the demo session from my side. Going back to the presentation, I will no longer switch to the full screen mode. I don't want to risk it. But just to summarize, so we've run a large-scale inference using Wherobots large GPU cluster. We've processed over almost 10,000 square kilometers of aerial imagery and got in that 370,000 building polygons. Those polygons cover 46 square kilometers, with 75% of all buildings having area smaller than 134 meters square. We've also saved all the results in iceberg tables so that other team members in our organization can also access them for later analysis. And with that, I'd like to thank you all for allowing us to showcase this short demo, this short presentation to you. If you have any questions regarding the demo, or any questions or queries about Spyrosoft, we're happy to take them. You can reach out to us either through a contact form on our site or directly on LinkedIn or email. Both me and Jarek Marcinak, our Director of Geospatial Services, are happy to take your queries and answer any questions you might have. Thank you.
Awesome. Yeah, thanks. Thanks for showing that all the way through and bringing that all together, Michael. I did launch one more poll, if you don't mind jumping to that one. And we have I guess we're right on time, but we have a few minutes. If anybody wants to ask a question, you can type it in the QA or just raise your hand and I will take you off mute live, and we could do that. Otherwise, we could hold here for a few seconds and then we will just call it a day. I will launch one final poll. So if you don't want to come off mute, but if you do want to interact with anybody or take a deeper dive with anybody from the group today, just let us know. We're glad to reach out and set up a meeting on any of the topics, deeper dive, your project, and see how we can help out there as well. So thank you for those answering. If there are no other questions, yeah, we'll call it a day, and appreciate the time. And thanks for those that sat through the whole thing twice. We appreciate it. Have a great day.
Thanks, everyone.
Thank you.